Good morning, everyone. Today is June 15th, 2019, and this is the John Chappell Natural Philosophy Society Science Chat. We meet here every Saturday at 10 a.m. EST or 7 a.m. Pacific at Fuse. Same place, same time. And we can be found at naturalphilosophy.org. And we're active in social media, so see us on YouTube or Facebook. And we're always looking for help. So if you would like to help, you can go to hq.naturalphilosophy.org and get involved. And our rules of conduct is please be respectful during the discussions and limit your discussions to science and math, and please no personal attacks. Now, our conference is coming right up at the end of this month here, June 26th through the 29th. And so today is an open discussion. So we have Aberchek wants to discuss the Doppler effect. So let's see here. Let's take a look at the article that he has posted here about the Doppler effect. Let me put that up here, share app. Where did I put that there? I guess that's there. There we go. Now, he is on chat, so let me see if I can arrange the screen here. Okay, so can you guys see the main Doppler effect screen, and can you see the chat?
Yes, we can.
Okay, great. So he wants to do this by chat. So we'll see how this works. So if you guys will just watch. So Aberchek, so what would you like to discuss about the Doppler effect? So the Doppler effect is the change in frequency of the wavelength of a wave. Now, normally this is demonstrated with an approaching train. So it sounds at a higher pitch when you're approaching and a lower pitch when you are receding. So are you there, Aberchek? We're waiting for you to lead the discussion or ask a question or. Okay, yes. So go ahead and write what you would like to discuss about in the chat. Meanwhile, I'm just going to scroll down on this page. Now, this all seems to be fairly well accepted science here. So I'm kind of curious as to what you think us dissidents might be interested in. Now, I'm thinking that the Doppler effect is interesting because, according to these diagrams here, that the thing that's being affected by the Doppler effect can be demonstrated with these circular lines, which demonstrate a frequency. So in the application to light, Now, there's some controversy as to whether light is a particle or a wave. And since I would say that because light shows these Doppler effects, that shows that light must be a wave, because otherwise, if it was not a wave, then it would not have this Doppler-like behavior. And it shows it has specific wave crests, which can be affected by the Doppler. And I think they're pointing out that the Doppler effect itself was used to determine that, like, for example, the universe is constantly expanding. Since the Doppler effect will reduce the frequency of certain stars, so Abhishek, we're still waiting for you to enter something in the chat. Let's see here. Don't see anything in the chat. Yeah, I don't see anything in the chat either. Now, I was getting something out of your microphone earlier. I'm going to unmute you here. So can you say something, Abhishek? I'm testing your microphone. No, I'm not hearing anything, and I'm not seeing you type anything into the chat. So did you want to continue this discussion? Because we can't unless you put something in the chat. Can you have a look at the equations? Okay, certainly we can go and take a look at the equations there. So this is the primary equation here. So this is relating to frequency. And the frequency that is the emitted frequency compared to the original frequency. So it's a ratio of the receiver versus the sender. So that's a fairly simple relationship. Do you have a question about that equation? Or do you think it's not right? Does anybody else have any questions about or comments about the Doppler effect?
Only as it pertains to classical electrodynamics.
Well, what did you think about my comment saying that the appearance of the Doppler effect and light effects, such as electrodynamic effect, must show that it's a wave?
Yeah, I'd agree with that. But I was thinking more along the lines of whether a charge can travel faster than the speed of light. And I would say no. And it's different than, for example, sound waves, because a car or a train engine is not composed of sound waves. And yet a charge is composed of electromagnetic waves. And that's why I would say that a charged particle cannot travel faster than the speed of light. It'd be like saying a tornado can travel faster than the speed of sound?
Well, I think the problem with that is that the speed of light can a light wave can actually travel faster than the normal speed of light. For example, in water, it doesn't go faster than the vacuum speed, but it is definitely going faster than the normal speed of light through water. So that's kind of a counterexample, but it kind of shows that light wave itself can fundamentally travel faster than what the medium could normally sustain. And I would generally disagree with the idea that an electron is made out of electrostatic waves itself. I have a lot of problems with that particular idea. To me, the charged particle is like the car. It's a physical thing. It's not made out of sound waves. For example, we did the analogy, right? Like if your car was made out of sound waves, then you're saying that the car can never exceed the speed of sound because it's made out of sound waves. But I would disagree with that. I would say that the charge is as solid as an automobile, and it is not made out of either electrostatic waves or the equivalent sound waves. So Average asks, how is this formula derived? As if that there's some sort of basic mechanism here, and you could. And this is the result at the end of all those derivations. So that's not really explained here, I guess. But I would think that this may be one of those formulas that is simply derived from experiment. And that's one way we do science, that we observe the phenomenon. So we do an experiment where we measure your velocity, and then we measure the frequency approaching and the one preceding, and just by trial and error, we can figure out what the relationship is, just from the empirical data. So I am thinking that this particular formula is not derived from any mathematical sense. This can be derived directly from an observation of the data. Now I'm thinking that some of these pictures that they have here is trying to motivate, why this is true. And actually, interestingly enough, so they have some examples here of what happens when you exceed the speed of sound in a medium here. So like you're saying, Bob, if you exceed, then you get this funny pattern here, which basically looks like a sonic boom. So the particle is going faster than the wave propagation speed of the medium. But it is possible. But they do have some analysis here. Maybe this is where they try to explain where the formula comes from. So, Average, what do you think of the proposal that these equations were derived purely from the observed data? You have an input, you have an output, you figured out what the variables are, and just by sheer hacking, figured out this formula, which is not a very complicated formula. Good morning, Bill. Glad to have you here.
Good morning.
I'm going to discuss something about the, the Doppler effect. So, Bill, do you think that the Doppler effect formula, I'm showing it right here, do you think that was actually derived?
I can't see anything.
Or I would speculate that that was simply created based on empirical observation.
This conference is being recorded.
There's a bit of a echo going on here. Let's see, is the echo still there? No, actually the echo is still there. Here. This is an open mic. I guess you do, Bill. Yeah, Bill, that echo is coming from you. In any case, we'll have to keep you muted. So I don't know how well this discussion on the Doppler effect is going with Aberchecki in the chat there, and him not responding very quickly to the discussion here. But today is an open discussion. So I was wondering, did anybody else have any topics of discussion they wish to talk about? Or y'all just want to hear me blab on, which I can do. So one thing I was going to look at today was what's going on with the CNPS conference. So that is coming up at the end of this month here. And let's see here. I'm going to just share the rest of my screen here. Let's see. Now, the other problem was that Aberchecki was only chatting to my private chat. So, okay. Well, Aberchecki, if you want to continue on with that discussion, we can, but you'll have to chat to the public group, and you'll have to be a little bit more chatty. Okay. But let's go on and see what's going on with the status of the conference this year. So this is the conference page this year. And these are the people who have signed up to go. So far we have 18 people. I see James Carter has signed up. That's good because he's a local scientist here in the Seattle area, and he's got a whole theory on atomic structure based on toroidal rings. And we have Musa, who's coming all the way from Africa. I think he gets the award for person traveling the furthest, but he's a regular attendant of these conferences. Raymond Gallucci, he's an interesting guy because he actually doesn't have his own theories, but he comments on everybody else's. And of course, I'm going. And James Martin's coming. So James is a frequent visitor to the science chat. And we have Gerald Pollock, who's our guest speaker here at the University of Washington. He is a university professor. And let's see, we also have Cynthia Whitney, who is like one of the founders of the MPA. And we have Jeff Yee. We had him virtually last conference, so it'll be great to actually see him live. So that's what's going on. So I'd like to see more people sign up to the conference. And if you can't sign up, then You still don't have any excuses because you can join virtually. And we'll be recording all the sessions later on YouTube anyhow. So that is what's going on with the conference this year. And apparently you'll get this nice t-shirt, Science Woke. And there's a conference room we'll have in the University of Washington. And they have some special accommodations at the University of Washington. And we'll be having an awards banquet. Now, one of the things I'm doing in the conference this year is I'll be presenting 2 very short papers. So I took 2 major ideas and condensed them all down into a single-page paper, which is how the electrostatic field works and how the magnetic field works. So that was my little challenge, to compress the explanation of those 2 major physics phenomenon into a single page. So I think these phenomenon are interesting because they are still 2 basically phenomenon which are not very well explained in mainstream physics. So it's kind of funny that these 2 main forces, which is the electric force, which is described by the Coulomb force law, which is we understand exactly what that does, and we can engineer all sorts of things around it. But if you ask somebody what charge is, people will say, well, I don't know that anybody knows what charge is, or they'll just shrug your shoulders, or the honest answer is that they don't know. And similarly, we have the same problem with the magnetic field, which is people know what the formulas of the magnetic field are, and we can certainly engineer things using magnets, but don't have any really deep understanding about how either of these 2 things work. But I claim that I do know exactly how these things work, so much so that they can be explained in a single page, right? Doesn't require long, lengthy explanation. So let me just show you, and I want to get your guys' feedback, so don't be shy. It's a lot of people, I like to just be polite and just listen, even though they just totally disagree. But I don't think you should do that. I think if you disagree with what I'm proposing here, that you should say, I totally disagree, and then let's chat as to why, because this is what we do in the science chat. This is not science lecture, this is science chat. So let me see whether I can, let me put the chat someplace else here. I need to get rid of that. Undock chat. Let's see here. Now there's here we go. You magnify this. Okay. So let's talk about the electrostatic field. So the fundamental question is, how do opposite charges attract and similar charges repel? What exactly is charge, and what exists between these charges that allows the transmission of these forces? So in this paper, I try to explain the electrostatic force as being the result of a phased wave interaction between positive and negative charges, and that these waves are mediated by a special neutrally charged medium which transmits both the normal electromagnetic waves and a special high frequency wave that actually makes up the electrostatic force. So that is the basic idea here. So we have to consider that there could be various ways to two objects to appear to just spontaneously approach each other. That's what charges do. And at the most basic, you have to basically consider that observation, that you have two things, and normally we think that if you have two things, that they're just going to stay where they're at, right? Nothing is going to cause them to do this, which is to attract each other, and in fact, accelerate at each other, right? So that's the mystery. What causes something to go towards each other, right? So I would suggest that the only times we see things come towards each other is basically if there's a region of low pressure between the two objects, right? This is why vacuum cleaners work. Because what's happening is that, you know, if you have like a ping pong ball and a vacuum cleaner, that what's going on is that the vacuum cleaner is creating a region of low pressure between the hose outlet and the ping pong ball. And what actually happens is that it isn't really an attractive force. It's actually that the reduced force on one side of the ping pong ball is not now being resisted by the higher pressure on the outside of the ball. And the ball is actually being pushed into the vacuum hose. So in this way, there isn't actually any attractive force. And I would argue that in Newtonian physics, the only thing you have to work with is actually collisions, right? Particle A hits particle B and causes it to change its trajectory. That's the only concept we have to work with in Newtonian physics. There's no concept of where object A is just sitting here and then object B just goes, oh, I like that object and I'm going to go towards it. That just doesn't happen. So I think that's an interesting, it's an asymmetry. There's between attraction and repulsion. When it comes to Newtonian physics, you know, neither of those concepts exist. The only thing that exists are collisions that cause other particles to go off into different trajectories, right? So if we observe anything where we see like two objects come together, we need to probably think of it as those objects actually being pushed on the outside. So I like to use a billiard ball analogy. So if I have two billiard balls and I see two of them come together, the only way that could really happen is if two other balls on the outside impacted those billiard balls, thus causing them to then start moving together, right? So that is one of the basic premises that I have about this paper, in that anytime we see attractive or repelling effects, it must be due to some kind of pressure difference. So what do you guys think of that? Is that a reasonable concept, that when we see charges moving around on their own, that there must be a pressure difference? So I'm going to open it up for discussion on that particular point. Agree or disagree? Or do you think there is something else that's causing charges to attract or repel? So I'm going to start picking on people. So Bill, what do you think?
I just unmuted myself. I was going to bring up the fact that William Hooper at the University of California at Berkeley performed a number of experiments on electric and magnetic fields. He was able to show there are three types of electric fields with different properties and three types of magnetic fields with different properties, and none of these six fields have the same properties. In other words, he measured 13 properties of fields, and no two types of fields have the same set of properties. So how do you explain that in terms of the approach you're taking?
Well, quite frankly, I don't. I think that's probably too many properties. I think in physics, we're trying to reduce things, and if there are 13, we'd have to discuss that, although that's not really the point I'm trying to discuss here, because you're just discussing the nature of the electromagnetic field. And you can find these properties, like some of them are shieldable, some are not shieldable. The magnetic field, when you move it around, seems different than the magnetic field, which is static. And all of those things should be explainable, and maybe those can be explained. Although what I'm talking about right now, and I wanted to get your opinion on, is this idea that, you know, you have a positron and electron, or even if you have like two billiard balls sitting on a table, if you see those things come together, that must be due to a pushing effect. I'm just basically arguing that by Newtonian physics, the only way you can get forces is if something is pushing you, right? So that's the question I'm asking you. Does Newtonian physics force you to conclude that all forces must actually eventually be a pushing force, since that's the only thing we have available?
Well, these forces that Hooper measured, they are more types than just pushing and pulling, and that the fields are exerting. And my question is, what do we do with these experiments that don't agree with our theories? Do we just ignore them?
Well, I believe that if you have a legitimate experiment and produces an empirical result, it is up to your theory to include it. That's always an interesting challenge. If you have a hypothesis, and then you run an experiment, and it will either agree with your hypothesis or it will disagree with your hypothesis, either adding information to support or information to take away.
Well, in this experiments that Hooper did, he didn't have any hypothesis. These were just empirical results, and so so they don't depend on, you know, assumptions or other notions. Just like when they were measuring Coulomb's law, you know, and Ampere's law, they those were empirical laws. So what he is finding is that there are 6 types of fields. There's static fields, there's time-dependent fields, and there's what I call cross-product field. But anyway, these 3 types of fields for both electric and magnetic fields can be confirmed experimentally. These experiments were done at one of the leading universities in America, and no one has refuted them in almost 50 years. So the question is, do we just ignore it, or what do we do?
Well, that's what we do as dissidents. We try to explain theories that may explain why those things happen. Right now in mainstream, like I said, they don't have a really good, you know, model for how the electrostatic charge actually works or how the magnetic field works. So it's kind of, you have to actually propose a hypothesis before you can see whether it matches the empirical results you refer to. So it's not that they're being ignored, but when you don't have a clue in the first place to incorporate those empirical results, I mean, even the simplest empirical result, which is Coulomb's force law, it's like, if you don't have a hypothesis on how that works, then how can you say that it agrees with the empirical results that you clearly measured, right? And so there's no need for anyone to dispute the empirical results, but you do have to have something that matches, right? So, for example, if I would like my hypothesis here is that all forces are due to something being pushed, like from a low pressure to a high pressure, you're going to get this differential effect where it will push particles around out of their normal inertial trajectory, right? But then you could say, well, if that were true, and if you create a low pressure region between, say, two particles, then you would probably see them come together, and maybe they might accelerate at each other. Well, I guess they would have to accelerate at each other as long as there's a low pressure region existing between the two particles, that would gradually speed them up, right? So I think that would probably be consistent with that picture, that you have an acceleration of particles, not just the particles would approach each other at a constant rate. I suppose if the attraction was caused by just a single impact on the balls, then they would come together at a linear velocity. But that's not what we see. What we see is more like a low pressure area that causes these two particles to not only come together, but to accelerate faster and faster towards each other. So that is an example of a hypothesis, right?
In the empirical laws of electrodynamics, there are velocity-dependent effects and acceleration-dependent effects. So, for instance, if I have two particles, say an electron and a positron, and they attract one another, they start accelerating and getting higher velocity as they approach one another. And that causes additional radiation to come off before they even collide or get together. So you have those are some of the empirical laws of electrodynamics, and we measure them in accelerators and everything. So how do we explain this radiation when electrons and protons approach each other in accelerators and they start radiating and give off some of their energy? How do we explain that with the way you're approaching it?
Well, I would say that I'm taking a hydrodynamic approach, and that I'm thinking that there is a medium between any of these particles. Now, naturally, I would think that if there is a medium, and if you move any particles through any medium, that like a boat through water, it's going to leave behind some waves. It's going to create, like a bow wave. It's going to create some kind of shock wave that as you move any electric particle through, it's going to definitely have some effect upon that medium. So that's how I would kind of explain that as a hydrodynamic analogy, that you have a medium. Anytime you put anything moving through the medium, it will have some effect. It's going to have to push some things out of the way, and when you push things out of the way, you get waves. So I'm thinking that my hypothesis here would be satisfied by the empirical observations that you don't need to do anything other than accelerate a particle to see energy come off of it. Now, maybe you do have to accelerate it, probably particle hitting at constant velocity might not actually emit waves. Is that true, Bill? You have a particle that's not accelerated. So in your accelerator, you finish doing the acceleration.
Well,
assuming a linear accelerator, so that it's not even turning, does just a moving particle produce any detectable energy?
Okay, well, first of all, a couple of things you got to notice. In accelerators, whenever you accelerate a particle in a circle, so it's just going in a circular orbit, in
going a circle, that in itself is an acceleration. So
That's right. So it continually radiates off when you're doing that, and and when you have it going in a straight line at constant velocity, it doesn't radiate. So
that's kind of two contradictory things that you have to empirically, that's a very important observation, that only accelerating particles are emitting this energy, but constant state particles don't. So your hypothesis would have to account for both. And I suppose if I were doing a strict hydrodynamic hypothesis, then that would be a contradiction, because even a boat heading at a constant 30 miles per hour should still leave a wake, right?
Mm-hmm.
But in this hypothesis that I'm coming up with, I would have to explain why is it that the boat heading at the constant velocity does not leave a wake, but yet the one which is accelerating does. So, and in order to accept that kind of difference, then I would have to make some modification of my hypothesis, which is different from just a straight water analogy. So I would have to do something like saying that and this might be a bit ad hoc, but this is what we do. So we take our initial hypothesis, which is just a water analogy, and we see that it doesn't accept this idea that going at a constant speed doesn't cause any waves to be emitted or energy of some sort to be emitted. So I would have to say something to the effect that the media is such that it absorbs and returns back to the object all the energy that it receives. Because this is another problem we have to explain about why objects travel is Newton's first law, which is why is that particle traveling at a speed, retains that speed, it doesn't slow down. And this gets to the whole nature of inertia and how that actually is able to store energy. Because in some ways, you think about it, when you fire a bullet and it's like halfway across the room, and if you examine the bullet and you look at it, you take a picture of it, and maybe you do some experiments on it, and you find that, it's just an ordinary piece of metal, right? There's nothing, it's not hotter, or, it doesn't have a wound up spring in it. It's, for all we can tell, it's the same bullet. But yet when it goes and it finds its way, hits the wall on the far end, we find that bullet has a tremendous amount of energy associated with it. So the question is, where is that energy being stored? So I would say that energy is actually being stored in the bonds of the media that it's going through. That as it has to break apart and push aside the media, that as long as you're heading at constant velocity, it can get out of the way, and then it stores it as if it were a spring, and then as the object passes, it returns 100% of that energy back to the object as it goes by. Then there's no frictional effects at this super submicroscopic, ether media level. So just like a spring that is constantly stretched and then releases energy back to the particle, it keeps the particle going forward, and the media itself is instantaneously storing that energy, which we recognize as kinetic energy, right? So in that way, if the object is moving at constant speed, since this process is like 100% efficient, if it's 100% efficient, then it does not have any energy available to emit any observable energy to the outside world, if it's being 100% absorbed and restored, right? But in the case when you're undergoing an acceleration, then what we have is that there is some extra energy which is available to create the wave, since it's moving faster than what the media can normally accept at 100% efficiency, I would say. So that's kind of an example of how you can start with the hypothesis, which is like straight water hypothesis, find a problem with that hypothesis, and that you would normally predict that even constant speed objects would leave a wake, and then come up with some explanation, good or bad, that you add to your hypothesis to say that at constant speeds, you are absorbing and releasing the energy, the kinetic energy of the object, actually storing it, and therefore that's the case where you don't emit. Now, like I said, that's kind of the way that science goes, is that they find the empirical evidence, and then people go and they mess around with their theory until it kind of works, right? Now, that may be legit, or it may just be completely just ad hoc. Ad hoc meaning that the only reason why that explanation exists is so that your theory doesn't get thrown out otherwise, right? And science does a lot of that, right? But in any case, so getting back to this whole question of what is the electrostatic force, and remember, the thing we're trying to motivate here is why is it a positive charge should attract a negative charge at all, right? So far, I've proposed that it must have something to do with the particles experiencing like a low pressure area versus a high pressure area, and that everything is a push. So I'm saying that the fundamental reason why the negative charge must go towards the positive charge is because they're being pushed towards each other. There's just all this activity that's going on, and if you have a low pressure region, then it's just that the outer presses are going to be more than the inner presses, and then that's going to cause your particle to change direction as a matter of Newtonian collision. So that's the main motivation there. But in order to do that, then you have to actually have some kind of medium, some kind of fluid, like air or water or something, right? So what could that possibly be? So this is what may be mythically referred to as the ether, as something which fills all of space. So we have the positron, the electron, and we have something else in between them that's bouncing around like air that could possibly be impinging on these particles and pushing them around. So basically any particle would do, it could be like a particle of air, particle of sand. Of course, we know all those things are too big, and if it were either of those things, we would certainly observe it. So if the particles were apples, we would see that we are in a room filled with apples, but obviously we're not. So we don't see the apples. It couldn't be an apple, right? But it has to be something. I would say that in order for an effect to actually happen upon the positron and electron, it must actually be as solid and of the same nature as the positron and the electron. Otherwise, how could it impact and hit like a billiard ball? I mean, billiard balls impact each other because they're very similar types of materials. So the question is that what could be out there that we could possibly not see, but yet is made out of the same things as positrons and electrons? So my hypothesis here is that it's just more positrons and electrons. So that's what I propose that we have as a medium, is that we have just more positrons and electrons. So now these positrons and electrons may not necessarily have really any properties other than the properties we associate with solids. I mean, they wouldn't even possess maybe even an attractive or repelling effect. They're just there, right? So you fill all of space with these positrons and electrons. And there is actually some significant mainstream evidence that suggests that this is actually true. And it's usually referred to as the virtual sea. And there's certain experiments like the land shift that actually specifically indicate that the only way that particular experiment can work is if there is this sea of positron and electron charges that exist everywhere. And it just seems to be the simplest thing to do. I mean, I could propose that the particle is like, I could call it an FP, a fundamental particle, right? Something which is different than electrons and positrons. But then I'd have the problem of, okay, now I have to go find that particle, right? Even though no particle accelerator, no experiment, nothing has ever indicated the existence of this particle. And a lot of dissident theories, ether theorists will do that. They will propose some other mysterious particle and give it its own name, right? So, but I tend to disagree with that. I say that if you can find a particle in the world, which meets your requirements, and it's a known actual particle, then you should start by using that. So that's what my theory does as a fundamental act of its hypothesis. It says that what space is, I would say that space is filled with this positron electron C to satisfy the requirement that we need to have something which can create a pressure differential on the outsides of positrons and electrons to push them together by Newtonian mechanics, right? So furthermore, I would say that they likely did this pair off with the positron, the electrons, they pair off, and they basically form a neutral particle. Like I said, any neutral particle would serve the purpose that I'm looking for here, which is to create a pressure differential. And so that is the second proposal I'm making here in order to motivate how charges work. Now, surely some of you guys have some objections against that. So I've just filled all of space with positrons and electrons. And I know some of you probably don't like that. So I know Michael, you have definitely an ether theorist, and that's definitely not your theory.
Well, in my model, there was initially a universal oscillation which transitioned to a universal vibration, and that when you have vibrations, you have elemental units which are all the same because they're elemental. They're all the same size, and they interact by direct vibratory contact, so their interactions are perfectly linear. So this is where everything starts. The underlying ether is the basis for all the larger unit transmissions and
yes, so we do know where you're coming from. That's why I'm asking you the question. So, but I am saying that in opposition to that, now both of our theories can't be true at the same time, right?
Well, if you have this underlying ether and then you have these vibratory patterns in the ether, which may be similar patterns or they may be dissimilar patterns of the vibrations, which are either mutually interactive or mutually definitely not interactive. This would be a basis for what you're trying to say. But then you have other questions too, like why is there magnetism? Why is there gravitation? And then you have the idea of vibration, where there's has to be an empty space to allow for vibrations of the ether units. There has to be an empty space too, a very tiny one. And so if you have ether units which are interacting and aligning and training and forming larger units by their interactions, then you also are having an elimination of that tiny space because they're connecting up, and so they don't no longer interacting elementally, but rather they're making bigger units. So now, if you have a bigger unit, you want to start with a bigger unit. You already have had the interactions of ether units to make this larger unit, this positron or electron. So to me, it's not a starting point. It's already an end point. And then you have to go back to the ether to really understand basically what's going on. And to try to make sense of it just on the basis of quantum and even inertial observations, it's not really the way to go. You've got to look at the ether as the basic underlying motivator, and the way the the vibratory pattern is set up, and then eventually they will form larger etheroidal units by aligning and training and so on. And then you get the larger etheroidal units, which transition to quantum units, and the quantum units have their own dynamics, which we are familiar with the interacting quantum units. But the underlying dynamic is different because it's vibratory. I mean, that's my model.
Well, I mean, I would in some ways say, yeah, I have a lot of agreement with that, because there's a lot of vibrations involved in my theory, which you'll later see. But I would say that, you have your fundamental ether units, and see, that's what I'm claiming is the fabrication. Now, that doesn't exist. I'm saying that in my hypothesis, that the things that exist are the electron and the positron, and those exist fundamentally. They're not composed. I guess that would be another tenet of my hypothesis, is that, and this is very different from a lot of dissonance theories, but the idea here is that it is the electron and the positron which are absolutely fundamental. Now, in some ways, my theory does not explain what those things are. But since we know they exist, I mean, we can see them, they leave tracks. There's a ton of experimental evidence that suggests that the things that we call positrons and electrons totally exist as much as an apple and an orange I might hold in my hand. The positron and the electron exist, and I say they exist fundamentally. So they're not made out of etheroidal fundamental particles, because all the experiments we have ever done, no matter how hard we try, cannot break an electron into different pieces. You just never see it. Now, there might be some experiments where you might maybe see something that might be consistent with something, but really we've never seen an electron break into anything ever, really. So that's why I would assert that all the scientific evidence says that, unlike your theory where you're proposing that an electron is made out of etheroidal units, I'd say that's completely unnecessary. And you just start with electrons and positrons, because even if you have your etheroidal units, you still have to deal with this problem of why is it the electron and the positron come together, right? What is the charged field? What is that? Now, I suppose it could be a wave in your etheroidal particles, but I think it's just simpler to start with the fundamental particles we actually know, even mainstream would agree with me, know exist, which is positrons and electrons, and say that all of space is filled with that thing, right? It's not your etheroidal particles. It's just
what I claim is that what my model has that all these other models don't, including yours, is origins. So you have to start from the beginning with something, and so you have space and you have an oscillation of space.
Yeah, but I would argue that is a fantasy, that is fiction. I don't reading that fiction.
I think that's the only logical beginning point, is that you had space and you had elemental point localities of space that were mutually oscillating, and then they combined, adjacent pairs of units combined in a yin-yang fashion, and then by necessarily having to revert to singleton units, this broke the symmetry of oscillational space, and then you had
but this is, I guess,
independently vibrating
I'm trying to make here, which is that you're right, that we do have to start from somewhere, right? So you can have the origin story for the electron and the positron, which I think would be a good thing. I haven't seen one which seems convincing. All the origin stories I've heard for the positron electron sound like fairy tales to me. So that's why I choose that as my starting point, I don't start there. I start with what we know, which is that we know positrons and electrons exist. Given that, like you said, I don't have an origin story, but I'm saying that I don't need an origin story because the thing that I'm motivating is known to clearly exist, positron and electron. Like if I had a whole ether theory based on the existence of apples, then, the apple may in fact have an origin story. It came from the farm, it grew up, it came from a tree. But really, nothing of that would really matter if my theory just depended on the existence of an apple and the properties of apples, which in mass create the other observed properties we see, like gravity and magnetism and charge. That would all work out perfectly fine, even if I didn't know the origin story of the apple. And so, but all of the evidence about the electron does not present it as being any kind of combination of anything. It's, as near as we can tell, the most fundamental particle there is. And we've done a lot of experimentation to show that that's true. Electron is not made out of anything. It's not made out of fundamental particles. So if it were made out of fundamental ether-orbital particles, I think we would have seen that by now. We would have seen it break up into a spray of, however many ether-orbital particles we think it's made out of. But we've never seen that, so that kind of says that your origin story is wrong. We have no experimental evidence to support your origin story.
But we have seen that. We have, but with the experiments of Winston Bostick, he created toroidal rings out of the field and showed how to make an electron from 3 of these fields. And those are experiments, and they've been reproduced by other people. But I have another question for you. The proton and antiproton do not decay to another particle. Why aren't they the fundamental particle if the electron and positron are? Because they don't decay to something either. They can go together and disappear, but they don't decay into any other smaller particle. You would think that the proton and antiproton would decay into electrons, but they don't.
Well, there are experiments which clearly show that the proton does clearly contain 3-point objects. And that's not an experiment that we can do on an electron. So that alone tells you the proton is a composite object of at least 3 things. So that's definitely the motivation between the difference between protons, antiprotons, and electrons. Plus, they have, different mass. So this is the difference between a particle which can be clearly shown to be composite, like the proton, and particles which cannot be shown to be composite, which is like the electron. My assertion is if the electron was composite, then some degree of collisions, which is what we do in these accelerator experiments, would have shown it as breaking up into something smaller than an electron, but we've never ever seen that. Or we bombard electrons with other electrons or other electromagnetic waves, or however the experimenters do it, we find the difference between the proton and the electron. Big differences. Proton definitely has structure. Electron, no structure that we can tell.
There's a problem with the electron having no structure, and that is we have the equation E = mc squared. And so the mass is related to some kind of energy. In the work that Winston Bostick did, the mass is a function of the vibrational energy of 3 toroidal rings. And that vibrational energy determines the mass. And more complicated elementary particles are made of more of these toroidal rings. And so they can have more modes of vibrational energy, and that causes them to have a larger mass. And
well, certainly that's another viable hypothesis.
Yeah, well, I've done a theory of elementary particles, and I can predict all the known properties of the 96 most confirmed elementary particles, and I can predict not only their charge and their spin and their decay mode and what they decay to, but also their mass. And so that's something that needs to be handled in some way with the approach that you're taking. The approach that you're taking would work very well in some ways if your electron, instead of being an electron, was just a Toroidal ring. But you can't use them in quite the same way because you can't define mass and that sort of thing. But and you can't make all your elementary particles out of electrons and positrons.
Well, I don't know. I would tend to disagree with that. I think that you can make every single particle out of positrons and electrons. You know, I was challenged by some guy on the internet to explain, like, you know, well, explain a charge sigma, right? And yeah, I broke it down. I looked at the decay chains, and I broke it down step by step. And yeah, the charge sigma is like a combination of 23 positrons and electrons. It can be broken down that way. That's like the most complicated particle that mainstream physics recognizes, right? There's nothing more complicated than the charge sigma. But yet, it can be broken down into positrons and electrons. And I'm just kind of curious as to, you know, in your ability to describe, say, other particles and their precise masses and stuff, you know, at what point do you actually rely on the toroidal ring part of it? Because once you get to just the existence that the electron exists and its properties, then I'm thinking pretty much that's really all you need, in which case you're starting at the same place as I'm starting, which is that the electron exists. I don't care what it's made out of or how it's composed. It emits this Coulomb charge, and it has this much mass, and just start from there.
Well, the experimental data, when we scatter off protons and antiprotons, and even neutrons, we see that the components, which we would call quarks, have a charge of 1/3 and 2/3 the charge of the electron, which means that they're made of something more fundamental than the electron and the positron.
Yeah,
because
electron is not made out of quarks, right? So even mainstream would agree with that. An electron is not made out of quarks. Like I said,
no,
it's not.
but what I'm saying is, whatever quarks are made out of, they have a charge of 2/3 and 1/3 the charge of an electron. You can't combine an electron to get a fractional.
I would say that is an interpretation, because my hypothesis on that is that when you're looking at a proton, the simplest thing it could be, I mean, there's 3 things in there. The simplest thing it could be could be 2 whole positive charges and 1 negative charge. Now, the ratio there could be 2/3 to 1/3, or it could just be 2 to 1, right? I mean, ratio-wise, those things look the same. And it may be that you interpret them as being 2/3 and not a whole charge, just because that's what your bias is. Not that there's anything, I mean, there might be something experimental motivating that.
Well, we can measure it very accurately to be 2/3 and 1/3.
Now, I think you can measure the ratio very accurately.
It's not theory dependent. It's very easy to measure that. And,
yeah, well, I'm positive you can measure the ratio, but whether there was a 2/3 of a charge there, 2 charges, 100 charges, I mean, there could be 100 charges and like 200 positive charges and 100 negative charges in a proton, but you'd still measure the ratio as 2/3 and 1/3, right? It's not that there's
no, you're not measuring the ratio. You're measuring the actual charge of each of the components.
Well, I don't know how you could do that, because all these things neutralize each other. So it would scale and neutralize. That's what I'm saying, that you could, I could, when you're dealing with charges, you can only determine the ratios. You can't determine the absolute values, because, you know, if you have like 100 positive charges and 100 negative charges, if you do any experiment against that, you'll find that there's no charges. It registers 0. You couldn't do any experiment that would say there's actually 100 positive charges in here. You couldn't tell, because at the end in the experiment, anything external you could do against it registers 0. Right? There's no way you could tell there's 100, that the magnitude of the charge in that object is 100.
Hey, Franklin.
It is.
Franklin,
Mm-hmm.
So do we have magnets of different strengths or not?
Sure we do, but I haven't got to the magnetic field. I'm still busy
No.
trying to-
I'm not talking about the magnetic field. I'm talking about a strength of, you know, why couldn't you differentiate between a positive charge of a magnitude that's different than a positive charge of a different magnitude? Are there not differences in magnitudes with charges the way there are with a magnetic field?
Not if you're talking about individual positrons and electrons. A positron and electron possess exactly 1 unit of charge.
Okay, so would you be able to tell the difference between a group of 5 positrons as opposed to a single positron?
Yes, you would be able
As
to.
far as the amount of charge involved, would there be a difference?
Yes, there would be.
Oh,
So
that's
if you're
all the
talking
bill
about
is saying.
unbalanced set of charges, you can most definitely tell that.
And that's believe that's what Bill is saying.
The thing is that I'm saying that when you start mixing it with species of the opposite charge, then you can't tell the difference. Like if I have a group of 5 positrons, I put some thing to measure it over here, I can definitely see the field strength is 5 times stronger. I can tell there's 5 positrons over here. But if I mix that 5 positrons with like 3 electrons, then there's no way that I can tell the difference between this group of 5 positrons and 3 electrons and just 2 positrons, right? It's going to look exactly the same as 2 positrons. I can't tell what the absolute value is of the components of that composite object. All I can do is see what the result net is, right? Same thing.
Do we know weights of positrons and electrons like we do for protons?
Of course we do, but there's no point in adding positons and electrons to get the weight of protons.
But then couldn't you tell because of the weight factor as well what you're dealing with?
No, because the mass of an electron is like 1,900 times smaller than the mass of a whole proton. If you add together, and this is the same problem with quarks, even mainstream, that the mass of the quark or the mass of the electron, you add them together, is nowhere close to the mass of the proton. Something happens that causes the mass to greatly increase. I mean, the mass of, even made by mainstream, the mass of the quarks only account for 2 or 3% of the mass of the observed mass of the proton. So definitely one rule you cannot apply is that you add together the masses of the components to get the mass of the proton. I mean, even that's kind of one of the mysteries, but no, you really can't sit there and I suppose you could. I would say that you would have a point that you could tell the overall mass. Like if I had something that had five protons and 3 electrons, so that's a total of 8 things, and you could tell that would probably most likely have more mass than just 2 positrons, right?
And that's all I'm saying, and I think that's what Bill is saying.
That's not the kind of experiments that they're doing. I mean, they're just trying to tell between an individual proton, what is the charge ratio in that thing? And the charge ratio is, I'm saying, can either be 2 protons and an electron, or it could be 2 things with 2/3 positive charges and 1 thing with 1/3 negative charge, which is the conventional quark picture. But that's kind of how I explain that. I could be wrong about that, but
then you're back to the strength of the charge issue being wrong to match it up with a single electron like in a hydrogen atom.
what was I didn't get what the comment was.
So if you're just going to go with it's possibly just a ratio of 100 negative charges and 200 positive charges in a proton, for example, then you've got the scaling problem with matching it up to a single orbiting electron if it does orbit in a hydrogen atom. because all protons and all single electrons cancel charge-wise because they're equal.
Well, that would be perfectly fine. You could have 99 positrons, 100 positrons and 99 electrons in the core of a hydrogen atom, and it would be orbited by a single electron. That would be perfectly fine.
That's fine, but if you had 200 positrons and 100 electrons inside of a proton, if that's what made it up.
That would leave a net 100 charge.
Exactly. That's the point I think Bill is making.
No, that's not the point. That's not what we observe. We observe the proton as having a single positive charge.
I get that. But that's okay. Never mind. Go on.
I'm just saying that the experiments, that's my only point, that the experiments are consistent with both what Bill's saying and what I'm saying. The experiment doesn't, at least that's my claim. The experiment can only tell the ratio. It cannot tell the absolute value of the charge. Because and this is getting into different theories about, what the proton is made out of. I say it's 2 positrons and 1 electron. That is the simplest thing for it to be made of. And quarks don't exist. But like I said, that's a different subject for another time. Right? I have a whole other paper about why quarks don't exist. But we're still trying to get into this motivation of what is charge, right? So I've motivated that it must be due to a low pressure area. That low pressure area is created by a medium. That medium is just this sea of positrons and electrons. Now, I would say that we need something to actually be moving around. So I would say that this sea of positrons, electrons is in constant motion. That they're just constantly, it's like a box of ping pong balls you are shaking around constantly, right? This is what space normally looks. It's not a big stately lattice of just stationary particles. No, it's more like a box that you're just shaking rapidly. And this is the energy which is contained in just empty space. But even empty space contains this tremendous amount of kinetic energy. Everything is knocking into each other. And so if I put a ping pong ball in here that's black and one that's labeled red, I'm looking for some motivation that causes those two things to come together, right? Meaning that it's being impacted on the outside more than it is on the inside. So there has to be some difference between the positron and the electron, right? So my hypothesis here is that whatever electron and positron is that I'm saying that they ring like a bell, right? Like you take a bell and you hit it, and no matter how many times you hit it, you can hit it irregularly, it's going to ring out at its resonant frequency. So I'm saying that the positron and electron are like bells. You hit them, they ring out. They'll ring out into this medium, right? This medium that once you hit it, it's going to ring out, and it's going to just cause waves in these other particles, which also happen to be ringing. And the only difference between the positron and electron is that they ring out of phase. And that's the only difference. It's like if you have speakers and you hook the wires up wrong, then you get them out of phase, and that one will push in, the other will push out. That's the only difference. So why is that important? Why is it that important that we motivate that they're like the bells? So now instead of a box of ping pong balls, we have a box of like jingle bells, right? A whole box of jingle bells. We are just shaking like crazy. And the only difference between the ones I paint red and the ones I paint black is that they're ringing out of phase. That's the only difference, right? So why would that be important? The reason why that's important is because we know that when waves come together, they can either cancel or they can add. So I'm motivating that when you have waves coming out of the positron, that when their waves come together, they always add. And then when you have waves between the positron and electron, those always cancel. So when you have canceling waves, that means that there's less energy between those two particles. And this is what motivates the low pressure area, right? So because between the positron and electron, we're creating less waves, that allows all the other waves on the outside of these particles to push them together, right? So once again, that's a push, because I'm also motivating that all deflections are Newtonian nature due to collisions. So what we have here is that we have more collisions happening on the outside of the positron electron than is happening between them, because between them, the waves, the energy waves that these things are sending out are canceling. So it's kind of a super chaotic environment. And just on average, you see this pushing mechanism that's happening between the positron and the electron. So I mean, it's a very simple concept. That's why I can explain this whole thing in like under a page, right? It's not very complicated. And it can be explained quite simply as just saying that all of space is filled with positrons and electrons. Positron and electron ring at opposite rates. The waves that they generate cancel, creating regions of low pressure, which then force them together. So now we can answer the fundamental question of what is charge, okay? So when we talk about what is charge, it turns out that that is just a field, because we think there's an electric charge creates a field. What is that field? That field is the waves that are coming off of the electron like a bell, just like a bell creates a field of sound. An electron creates a field of electromagnetic waves. And what we mean by charge is that specific emanation of that wave field from the electron or the positron. So a lot of people will say they don't know what charge is, but I will say I absolutely know what charge is. Charge is a wave that has been emitted by positrons and electrons, and it's an ordinary wave, just like a radio wave, just like a light wave, but at an extremely, extremely high frequency. In fact, I would claim it's at the highest frequency possible in the universe. And that's important because one of the main objections of this whole idea is that, you know, if the positron and electron are just a little bit off, you know, they're not going to fully cancel and they're not going to fully add, right? Because the wave can always exist, you know, on some continuum here. So if that were the case, then nothing would stick together. This whole idea doesn't work because all of the phases, none of these things would actually fully add or fully subtract. Therefore, should be no forces, right? So that is brought up as an objection. But I would say that it's actually not that hard to believe. The analogy I always bring up is that in your computer, this is exactly what's going on, in that your computer can fundamentally only hold two states, a 0 and a 1. And they're changed, that state change happens only at the click of your CPU clock, right? So everything in there is 100% in phase, right? So if you're looking for an analogy for why is it that, because I'm basically saying every single positron and electron has to be in the same phase and they have to be changing at exactly the same time, right? Same thing happens in your computer, right? Governed by a universal clock. So at some point out there in the universe, I'm saying, well, if you can believe that there's a universal clock out there, then that would motivate why all of these positrons and electrons have to be ringing at exactly the same moment. The other thing is that I think nature quantizes everything, that you can't take time and you can't infinitely slice it up, and you can't take distance and you cannot infinitely split it up. You know, if you allow that, then you get like these paradoxes, like the person who's shooting the arrow at the wall and it goes half the distance each time, and you'll find that it never will reach the wall. But since we do know it reaches the wall, there must be some smallest bit of time you can have and some smallest bit of space you can have. Now, if that's true, then if your positron electron has like two states, maybe in state and out state, and if it's doing that as fast as possible, then there can actually only be two states for a positron and electron. Because if there were any other states, then you could define a unit of time that is smaller than the smallest possible unit of time, right? Because if everything has to either be out, everything either has to be in, then the only two states you can possibly have are these. One has to be out, one has to be in, and once you get it started, it's stuck in that state, right? So that motivates how that might be, right? Okay, so surely you guys must have some objections to those ideas. So I fully explained what charge is and what the electromagnetic field is made. Let's see, did I answer all the questions about I proposed here, right? So I've answered the fundamental questions of how do opposite charges attract and similar charges repel, right? With the phased wave analogy. So what exactly is charge? Charge is a wave which is being emitted by positrons and electrons. That's it. And what exists between these charges to allow the transmission of these forces? Well, just more positrons and electrons exist between those two. And generally speaking, you don't see the charge unless you have a widely separated positron, right? Because some people think this is circular, that that the medium that I'm using to transmit the waves is actually made out of the particle that's transmitting the waves, right? But it's not. It's actually an economy of description. Once you have the positron and electron together, that basically is not emitting any waves, because all the waves that the positron and electron together are emitting are immediately absorbed by each other. So basically, it's not effectively not ringing anymore. I mean, it is ringing, but it doesn't have any outward effect on anything else, versus the independent electron, which is generating a very distinct wave out into all these other identical particles to create the forces. So that is the basic idea. So I'm going to open this up for discussion. I'll probably end things up a little bit earlier today because I got to get out of here a little bit early. So what do you guys think of that? That is the basic explanation and hypothesis to motivate why a positron should attract an electron. So, Jim, we haven't heard from you in the discussion here. What do you think of that hypothesis? And it is just a hypothesis. It could be wrong, could be right. But it's what I'm going with, right? To answer this fundamental question. Maybe Pal, what do you think, Pal? Is this something that makes sense, or do you have some objection? Why would this not work? Are you there, Pal? He might not be there. He may have stepped away.
I'm here.
Oh, Pal, so you've been listening to the discussion, so I've been trying to motivate why electrons should attract positrons. What do you think?
I think I'm on a different path, different track, different tack, and therefore it's very, very unlikely that you and I can agree on anything. In fact, you and I may even be harder to agree on anything than you could with Harry Ricker. And Harry Ricker and I have talked a little bit about this. And one time, Harry Ricker said to me that I don't know whether he was serious or joking. He says that the way I operate there is a chance that it might lead to something, or something to that effect. And yet, it is not that easy because the way, shall we say, nature or WEC or the creator operate is so different from we as humans operate. And unless there is some kind of a nexus between these two extremes, and they are extremes, um, in a way you might say uh, the way God operates, he sees operating us uh, as absurdly. And by the same token, I think most people, when they try to think of how does God operate, to man, God's ways are as um, as I don't know what to call it, as unfathomable. I mean, ununderstandable, unrelatable, and therefore, we have long ways to go if something is going to happen in our lifetime. I don't see, all the times that I have been following these discussions, and I'm not just talking about CNTS, I'm talking about other dissident groups, and mainstream science, and you name it, uh, and they all have had the same problems. Um, there hasn't been any progress by any of the groups in bridging the the ways of the man with the ways of the creator, because they're just in not only different dimensions, but they are of a different um, I don't know, other than dimension, um mis miscommunications, if any, misunderstandings, and therefore, I mean, to say that I am discouraged or some other people are discouraged would probably be an understatement.
Well, I think that's why, at the CNPS, we continue to try, right?
Oh
We
yeah, I
continue
admire.
to have this
I'm not saying there's
discussion.
anything wrong with trying. And the name you come up with it as science chat allows you to do that, because you're just being honest with everybody. It's just a chat. You don't have to understand everything you are saying, or you don't have to understand anything everybody else is saying. But you're
Well, I
chatting.
think though that's kind of the motivation behind why we do this and why we try and explain. I'm trying to get people to express why they think this doesn't work, because normally, and that's usually very difficult, not unless you have Harry on, in which case you'll just always say that you're wrong, and that's fine. But he has to explain why, right? And people need to I don't know, be able to get together and modify their thinking, because if you have like 100 people and they're all going off in different directions, then yeah, that doesn't look like any progress is being made, right? And that's seems to be what we normally have happen. But I remain hopeful that perhaps that these things can be wrestled from the mind of God, and we can figure these things out. And once we do so, we will hand the engineers much more powerful tools to manipulate the world with. So, for example, if we can figure out exactly what charge is, then for example, we can make a generator of charge, right? Suppose you could make a mechanical device that if charge is just this wave, you could create a really, really big wave. It'd be like creating an amplified speaker, right? So instead of like in old times before we had PA systems, people would just have to sit in a circle and talk, and it could only go out so far. But using the science of sound, we created a gigantic amplifier and a loudspeaker, which create a much more powerful force, right? But in order to do that, we have to actually know what charge is so that the engineers can work on devising a device that might perhaps increase the availability of that charge in like a smaller space. Same thing with magnets. We can already do a lot of things with magnets, but if we understood exactly how that works, then perhaps we could create, say, for example, better superconductors. Perhaps we could create more powerful magnetic forces other than using, say, electricity around solenoids. We could perhaps manufacture magnetic fields to exact shapes and sizes if we knew that what it is. Now, I didn't get to my other paper on the magnetic force. Maybe we'll get to that next week if we still don't have any other topics. But from an engineering perspective, I think we would be able to do a lot more if we knew what the fundamental basis of these forces actually is. A similar thing with gravity. If we knew what that was actually, then the engineers could then work on making things that either enhance or defeat gravity, right? Right now, we don't really know what to do. If you told an engineer that gravity is due to the bending of space-time, as far as an engineer is concerned, we have absolutely no idea how to manipulate that. But if we were to tell an engineer that gravity is actually it's just an electrostatic force, and some aspect of electrostatic force, because we know how to manipulate electrostatic forces, right? We can create regions of high electrostatic force or low. And then an engineer might be able to manipulate that, but we have to have some genuine knowledge of what that gravity force is before any engineer can do anything useful about it and create the flying cars we've all been waiting for. But I'm hopeful that we can do it, that it's not an impossible job. I personally see a way forward in like the work that I'm doing, and I continue to try and promote that. And, that's why we have the chats. Okay, so now we only got about 15 minutes, and I do need to end this chat a little bit early today because I got to set some stuff up and go.
Yeah, no problem.
So I think I'm going to end the chat early today. So I thank everyone for showing up and participating and listening to me rant about how the charges work. But hopefully you found some of that interesting. And I'm hoping that it's right. I'm trying to get some feedback on that, and I'm going to be presenting this at the conference as well. So maybe I'll get some feedback on that. But I think that will do it for today. I don't think I have any specific topics outlined for next week. So if anyone would like to present a topic, please email me at franklinhu@yahoo.com. But that will do it for today's meeting.